So this is kind of a part to the first lesson in Edgenuity, where it's relating relationships shown in tables to equations. So I'm going to look at these two tables right here. I have a horizontal table and a vertical table because you can see them in two different ways. And if I want to write an equation based off these tables, I have to make sure I'm looking at the tables and knowing which one's my independent and dependent variable. So I'm going to focus on this first table right here. Anytime you see a table, the top is always your independent variable. The bottom is always your dependent variable. And you can always ask yourself, the distance depends on the hours. It does not make sense to say the hours depend on the distance. So top is always independent, bottom's always dependent. I like to think about ID. That makes more sense, kind of like an ID, like a license. So when I am trying to write an equation, the dependent variable is always the one by itself. For distance, I'm going to use D. I'm going to write the dependent variable equals. So distance equals. The dependent variable is always by itself. So you're going to use a variable for hours. I'm going to use H. And then I'm going to look at my numbers, because the numbers are going to tell you what operation you're using. And I'm going to say, okay, how do I turn 1 into 7, 2 into 14, 3 into 21, and 4 into 28? So it has to be the same operation for all of them. It can't just work for one, it has to work for all of them. So I can say, okay, 1 plus 6 is 7. I try to the next one, 2 plus 6, well, that gives me 8. So that plus 6 will not work. Another one I can try is 1 times 7 gets me 7. Okay. 2 times 7 gets me 14. That works. 3 times 7 gets me 21. That works. 4 times 7 gets me 28. I know for all of them, I can say times 7. So what I'm going to do, I'm going to take my independent variable, which is my hours. I'm going to write H. And I know it's all times 7. So I can either write H times 7, or what you're going to see more often, right, dependent variable equals 7H. And it makes sense, because if H is 1, H is hours, distance would be 7. So 7 times 1 gets me 7. If H was 2, so instead of H I put a 2, 7 times 2 would give me that 14. So 14. So that equation's what makes sense. If I'm looking at this one right here, it is a vertical table, but it's still the same thing, ID. First one's your independent, second one's your dependent, no matter what. So when I'm writing an equation, I always want my dependent variable to be by itself coming first. So for dollars, I'm going to put D for dollars, equals. And now I have L for laps. So I'm going to think to myself, same thing, had I turned 1 into 10, 2 into 20, 3 into 30, 4 into 40. So I can say, okay, 1 plus 9 is 10. That works. 2 plus 9 does not give me 20. So I know plus 9 does not work. So I can try another example. 1 times 10 gets me 10. That works. 2 times 10 gets me 20. That works. 3 times 10 gets me 30. That works. 4 times 10 gets me 40. And that works. So I know for each one of these, I can do times 10. So I'm going to take my dollars, which is my dependent, equals my independent times 10. In this case, my independence laps, so I can write 10 L as a cursive L, so you don't see it's a 1. So the amount of dollars equals my laps times 10. So if I have 1 lap, 1 times 10 would give me 10. If I have 2 laps, I plug in wherever I see the L, I put a 2. 2 times 10 gets me 20. That works. Be careful. If you switch it and you say L equals 10D, that's backwards and it's not correct. And here's why. If I say D is 10, 10 times 10 gives me 100, not that 1. It doesn't make sense. The dependent variable always has to be by itself. This does not make sense. This would be wrong.